Good afternoon, and thanks to you for the invitation. I consider it a privilege to be asked to speak to any group, but to be able to do so with a leadership development group is a particular honor, so thanks again. Kairos Power is a mission-driven company, and we start virtually all our substantive interactions with a reiteration of that mission, which is to enable the world's transition to clean energy with the ultimate goal of dramatically improving people's quality of life while protecting the environment. Our mission underlies everything we do. In prior discussions with E4C groups, I've gotten questions about my career path, specifically how I ended up in a leadership position. So I thought, given the focus of this team, I'd do a quick overview of how I got where I am. After school, having first been a co-op with what was then Duke Power, I began as a reactor engineer at Oconee Nuclear Station. During my time at Oconee, I ended up in several lead roles for various projects. After several years of doing physics testing and fuel management at Oconee, I moved into Duke's new engineering and services company on a contract supporting the DOE high-level waste program, first in Charlotte and then in Las Vegas, working on the spent fuel repository. It was in that role that I assumed my first formal supervisory position. Also within Duke Engineering, I then moved into another leadership position supporting the mixed oxide fuel fabrication facility back in Charlotte. Before being pulled back into the power company proper to do new plant development, I broadened beyond simply a Duke leadership role to an industry consortium as well, the New Start consortium that was a collection of utilities working on jointly licensing the AP1000 and the ESBWR. After almost 30 years, I left Duke and joined Babcock & Wilcox on the mPower small modular reactor program. After B&W canceled that project, I spent 3 years in my own firm contracting with multiple advanced reactor interests. Happily, one of those clients made me an offer I couldn't refuse, and here I am. As I reflect on my path, I look back on the combination of events that got me where I am. There were certainly components of being at the right place at the right time. Certainly there were components of being willing to stretch beyond what might have been my obvious capabilities, obvious either to myself or to others or both. And the willingness to step into leadership roles in partnership, consortium, or industry forums. As those who have those sort of industry forums can attest to, there's a lot of value to just being willing to speak up, especially in a room full of people when otherwise things might be quiet on critical issues. So on to the main presentation content. Kairos Power is a privately funded company focused on the commercialization of the fluoride salt-cooled high-temperature reactor, or FHR. We'll talk about our technology in a moment. We were founded in the San Francisco Bay Area in 2016, emerging from a concept developed at UC Berkeley with cooperation from MIT, University of Wisconsin at Madison, and the Department of Energy's Integrated Research Program. We're currently at about 140 full-time employees, most of whom work out of our Alameda, California headquarters that you see pictured here, with a handful in the Charlotte office and a few in our new and growing Albuquerque location. Our development schedule is driven by an expectation of US demonstration by 2030 or earlier, with an emphasis on earlier, and rapid deployment ramp in the 2030s. Our design is a bit of a hybrid. So we combine the use of TRISO fuel, which is historically used in high temperature gas reactors, with molten salt coolant, borrowed from the molten salt reactor designs, but distinct from them in that our fuel is not dissolved in the coolant. We're actually unique in having molten salt as a coolant, but a solid TRISO fuel. And not pictured here, but borrowed from sodium fast reactor technology, is a low pressure primary system. Our commercialization target relies on competing with natural gas. We recognize we will have to do things differently, as do all new nuclear developers today. We start that by taking advantage of robust inherent safety that includes substantial fuel temperature margins as a result of the very robust TRISO fuel, retention of fission products in the fuel and in the coolant. One of the important aspects of the molten salt coolant is it has a very high affinity for hanging on to radionuclides. So the fuel form that we use is remarkably robust. It's been tested to temperatures in excess of 1500 degrees centigrade. So there are hundreds of degrees of margin against any projected accident scenario. In the unlikely event of release of significant radionuclide content from the fuel itself, we take advantage of that high affinity on the part of the molten salt to grab onto those radioisotopes and to hang on to them. And as I mentioned earlier, a low pressure primary system that limits the volatilization component of a hypothetical accident scenario. Combined with passive heat removal, longer progression times rather for projected accidents, and so forth, we end up with a significantly lower risk of release during projected accident scenarios. And we're confident this approach will reduce the capital cost of the plant, allow broader use of conventional materials and equipment, and result in a lower capital cost, one of the primary barriers to entry for new plants today. Another innovation on the part of Kairos Power is to challenge the conventional development cycle with more iterative development that incorporates the concept of rapid development and testing cycles, often testing to failure as part of prototype development. I'll show you a picture at the end of the presentation that's actually one of our labs where most of our design engineers are co-located with a lab facility. And when it comes time to conceptualize a component, more often than not, they simply go into the lab and build what they're designing in real time to see if it will work. The iterative testing cycle manifests itself in a number of test platforms and facilities that are shown here. The first is the Rapid Lab. It's as shown here, rapid analysis, prototyping, and iterative design lab. It's a lab that focuses on demonstration of concept for components for the plant. Does this widget that we've conceptualized, that we're designing, actually work? And again, a lot of that component development and testing is done in real time with the design. That lab is co-located with our headquarters facility that you saw a picture of earlier. I meant to mention at the time, it's a repurposed World War II era hangar on the former Alameda Naval Air Station, which is being repurposed for several industrial and residential purposes. It is a singularly impressive facility. If you ever get the chance to see it, you should definitely go do that. It's roughly 50 or 60,000 square feet of laboratory and office space, and it's a really, really slick place to visit. The second is the Salt Lab, which is intended to handle molten salt at temperature. The S Lab is also co-located with the Alameda headquarters facility, and it is being completed and commissioned as we speak. We have managed to return a select number of people to work in our Alameda facility, and their primary focus, of course, while maintaining safe operations, is to get the S Lab commissioned. The testing facility is the next iteration of our test cycle, and it's a component testing and fabrication facility that will be located in a new complex that we just stood up in Albuquerque, New Mexico. As not shown on here, but as a companion of that facility is the engineering test unit, also located in Albuquerque. and it is a reduced scale, non-nuclear version of our design. And it's intended to demonstrate proof of concept for individual components and for an integrated system, obviously on a smaller scale and not a nuclear facility. The final test facility is the U facility, or the user facility, which has not been cited to date, but we're working on that. And it will be a full-scale user operations and maintenance training facility. It will, in effect, be a full-size version of our reactor, but non-nuclear. So our intent is to build the U facility not only as a training facility, but also to demonstrate that we know with pretty high precision what it's going to take to actually construct the full-scale Kairos Power reactor. In the past 2 years, in addition to commissioning the Rapid Lab and the Salt Lab, we've completed pre-conceptual design of the Kairos reactor and are well underway on conceptual design. We're also in the midst of detailed design for the engineering test unit that I mentioned a moment ago. I run the East Coast office in Charlotte, and I'm happy to report we just announced the formation of a strategic collaboration with Materion Corporation to develop a reliable and cost-effective supply of salt coolant for high-temperature molten salt reactors. This coolant that we talked about a moment ago is a key component of the Kairos Power design, and under the agreement with Materion, they will supply beryllium fluoride, as well as expert technical consultation, key interfaces, and support services, and we're really happy to be working with them. Also, I mentioned the new Albuquerque facility for the location of the engineering test unit and the T facility. We took over that facility. It's an existing building that we'll be upfitting, as well as adding some additional facilities ourselves just a few months ago. That announcement was made right at the end of the last calendar year. Excuse me. We've also been very busy in licensing space as the most active developer in terms of pre-application engagement with the NRC staff. I should qualify that. There is another advanced reactor developer that has actually submitted a license application. The Oklo design is a microreactor on the order of a couple of megawatts. We are in pre-application space, which is the run-up to submittal of an application. Our plant is significantly more complex and larger than the Oklo plant, but we still anticipate learning a lot from their interaction as they go through their acceptance review and hopefully their actual application review. But in terms of pre-application engagement, we've sort of set the standard for what that looks like based on feedback from the NRC staff. We've submitted topical reports on the selection of principal design criteria, regulatory gap analysis, that is an assessment of the existing regulation to understand how we weave our way through any exceptions or exemptions, understanding that the regulatory framework today is based in large part, and for obvious reasons, on light water technology. So we've done a detailed analysis of how we will navigate the existing regulations, where we'll need to take different approaches and so forth. Scaling methodology for separate and integral effects testing, qualification topical for reactor coolant, for fuel performance, licensing basis event selection, which I'll touch on in a little more detail in a moment, and our quality assurance topical. For many of these pre-application submittals, we've already submitted revised reports reflecting resolution of NRC staff comments and questions with a significantly streamlined question and answer scheme that the NRC staff describes as a no RAI process. Those that have participated in the licensing process in the past will recognize this is a significant evolution in the NRC review. RAI refers to request for additional information, and historically it's been a very structured sort of bureaucratic process where the NRC staff will formulate questions. More often than not, the applicant will have the opportunity to review the questions, make sure that the questions are understood. Any questions go back to the NRC staff. The NRC staff then issues formal requests for additional information, the applicant is expected to respond to those questions formally, typically in 60 or 90 days, although sometimes it can take much longer depending on the complexity of the question. And then the NRC staff will take those questions and ruminate on them to see if the question was actually answered. Historically, RAIs can come back in 2 or 3 or more different rounds of questions, and it can be a very labor-intensive, time-consuming process. We've piloted a process with the NRC staff where we've short-circuited that process dramatically. So when we submit when we submit a topical report, the NRC staff will do a review, and then in lieu of this formal documentation cycle, they will have a meeting with them. They will ask us the questions that they have. We will, in lieu of a drawn out formal Q&A cycle, what we've done so far is incorporated our feedback on their questions into an updated version of the topical or revision of the topical, and gotten that turned around in much less time. And as a consequence of that, our topical report review cycle now is more on the order of a year, whereas historically topical reports can take 2 years or more easily to get through NRC review. So we do think it's a significant evolution in the NRC review. We have another half dozen or so topical reports teed up for submittal in the coming months. We've had uncounted numbers of phone calls and face-to-face meetings, back in the day when we used to be able to do face-to-face meetings, including several on-site visits by the NRC staff. When they do an on-site visit, they call it an audit, and it gives them the opportunity to look at detailed underlying documents behind your submittal that typically would not be submitted. We call it on the docket, not formally submitted, but available for review. So those on-site audits give them the opportunity to look at those detailed documents. We've had very good success with those interactions so far. In fact, in more than one case, they've looked at our documents and commented that the quality of our underlying documents is actually going to save them having to create some of their own documents that they might otherwise have to do for independent review. We've also worked with the NRC staff through our regulatory engagement plan to map out what our application path looks like for the actual license application, including initial discussion on application format and content that represents a new way of presenting and reviewing information in a license application. The historic format and content for a reactor license application is based on a standard review plan that's very heavily influenced by light water reactor technology, and is based on a sort of deterministic presumption of what the design basis accidents or accidents projected to result in the worst case consequences that you have to evaluate against. Many of those deterministic accidents simply don't apply to non-light water reactors. And so we have focused on a format and content and the establishment of a safety basis that's more focused on the actual risks associated with the technology. So it provides for much more focus on the safety significance of the portions of the design, and leaves us with the opportunity to simply set aside significant pieces of previous format and content for an application because that content simply isn't safety significant for our design. I'm also very happy to report that we've received a formal safety evaluation on our first topical report, the Principal Design Criteria topical report, just last week. We've also received several draft safety evaluations, and we're the first advanced reactor developer that's been through the full, not only the Advanced Reactor Subcommittee, but also the full committee of the Advisory Committee on Reactor Safeguards, which is an NRC advisory body, one of the many wickets that you have to go through in reactor licensing. We've been through that process with the subcommittee and the full committee on 2 topical reports now, and the final safety evaluations that will come as a result of those meetings are anticipated any day now. I want to take a brief tangent from my prepared remarks to talk about the licensing basis. You may hear it referred to as the Licensing Modernization Project. You may hear it referred to as a risk-informed, technology-neutral guidance on establishing the safety basis for an advanced reactor. It goes by many names, but this goes back to a methodology that's probably the most significant development in advanced reactor regulatory framework, certainly in the last couple of years. But in reality, it's sort of a culmination of decades of work, so it bears some discussion. Because the commission just voted last week unanimously to adopt this approach. What it refers to is setting aside those deterministic design basis accidents that emerge from the light water standard review plan. In light water reactor licensing, historically, there are several accidents that are prescribed that you have to evaluate against. And they have evolved over time, but they're a pretty well understood, pretty well characterized in terms of light water reactor technology set of events that you have to put your design through. And as I mentioned earlier, for non-light water designs, many of the accidents simply don't make sense. They just don't apply. So beginning about 4 years ago, we began looking, the industry, began looking very closely at what it would take to shift the regulatory framework so that you didn't have to spend a huge amount of time justifying why you're not using the light water guidance for non-light water design. And we came up with this licensing modernization project. To sort of generalize the approach, instead of taking that set of deterministic accidents, turning the crank on an analysis that for non-light water reactors wouldn't be particularly meaningful anyway, and then bolting on a probabilistic risk assessment at the end to help manage the risks for the operating plant, we take those processes and we turn them sort of 180 degrees. We do that by implementing probabilistic risk assessments, risk-informed safety analysis in concert with the development of the design itself. And as we iterate the design and as we iterate the risk-informed safety analysis, we end up with the dominant set of risks that come out of the design and out of the internal and external events that are postulated for licensing the plant. And so the involvement of the risk-informed methods early in the design and the characterization of the event sequences in parallel with the development of the design itself results in the actual design basis accidents that are relevant for the design being an output of the process, not an input. And moving the probabilistic analysis into sort of the mainstream licensing basis of the plant, as opposed to a bolt-on at the end of the process, provides that the establishment of the safety basis can be risk-informed right up front. It's a fairly arcane subject, and I apologize if I lost anybody in it, but it really is fundamental to establishing a new regulatory framework for advanced reactors, and that's sort of the key. So for those that aren't well versed in the work that's been underway in advanced reactor development in the past couple of years, I want to touch on some additional reasons for optimism. Small modular reactors have the potential to change the way nuclear energy is deployed in this country. Passive safety, which is pretty much the price of admission to new reactor development these days, changes the paradigm about what's considered important to safety. Extended accident progression times, which I mentioned earlier, similarly have the potential to help change the outcome in our insistence on focusing on worst case scenarios. That is, what we think of as worst case is now changing and becoming more realistic and becoming more focused on the actual design as opposed to some prescriptive imposed set of accidents. The design-specific review standards were an effort by the NRC staff a few years ago to take that guidance that was historically applied to all reactors and make them design specific to try to benefit from what the staff knows early in the review process about the design. While it wasn't completely successful, it did signal a willingness on the part of the NRC staff to begin thinking differently. Functional containment offers an opportunity to credit, in the case of the Kairos design, our fuel and coolant, and obviate the need for a huge, monolithic, and very expensive pressure retaining containment. A site boundary emergency planning zone that recognizes when the risk of the facility is low, another signal that acknowledges when a plant design reduces real and perceived risk to the public. The risk-informed safety basis, I spent a few minutes talking about a moment ago, an even larger nod in that sort of risk-informed direction, enabling a much more realistic design basis that doesn't focus on non-safety significant aspects of the design. Security by design. This is very much a work in progress, but it has the potential to enable a more realistic security profile and reduce the cost of operating these plants. Additive manufacturing. It could be a game changer when it comes to specifying and procuring components, even safety-related components. The National Reactor Innovation Center, or NRIC, and the Gateway for Accelerated Innovation in Nuclear, or GAIN, offer platforms for federal support for reactor development and deployment, including the recent Advanced Reactor Demonstration Program, which looks to put real federal money into a cost-share program to help develop and deploy advanced reactor technologies. The Nuclear Alternative Project just published a feasibility study indicating nuclear deployment in Puerto Rico could make sense, identifies some hurdles that we need to get over, including some policy changes that would be needed, but that would make sense from an energy security and economic standpoint. The Southern Ohio Development Initiative is looking at options for licensing a plant at a repurposed gaseous diffusion site. Southern Nuclear is developing a topical report on seismic base isolation. And the Nuclear Energy Institute, Nuclear Industry Council, several other non-governmental organizations and grassroots organizations, excuse me, are actively involved in advocating for and supporting new nuclear development and deployment. Among them, the UNCC Energy Production and Infrastructure Center, or EPIC, and our own E4 Carolinas. Excuse me. Finally, as we look out at one of our lab facilities in a photo that's actually over 6 months old, so it's even more exciting to see today, I'll tee up the question, why? Why nuclear? Why bother? It's expensive and, safety and waste and scary and all that. But here are the facts. Nuclear energy, under any objective metric, is the safest form of energy production ever. Even factoring in accidents such as Chernobyl, nuclear is safer than any other technology and is available very close to 100% of the time. And nuclear is required by law, by the way, to manage its own waste in a way that's virtually unmatched by other technologies. Nuclear is expensive to build and cheap to operate. Large plants are virtually impossible for many markets today because they're so capital intensive, which is why Kairos Power and many other advanced reactor developers see it as a moral imperative, frankly, to change that equation. And let's be clear, energy poverty is worse for the poor, at least in the short term, than climate change. The UN, for example, lists universal access to clean energy among its top 10 priorities, arguing for transition to renewable energy in poor countries. The Breakthrough Institute argues, on the other hand, that small-scale renewable projects to supply small amounts of electricity to subsistence farmers is not effective as anything more than a stopgap because it can't address energy poverty at scale. They say, quote, "There's no nation on earth with universal electricity access that remains primarily agrarian. Modern household energy consumption has historically been achieved as a side effect of electrification for non-household purposes such as factories, electrified transportation, public lighting, and commercial scale agriculture." I have friends who are climate change advocates and friends who are skeptics. My message to them is, to both of them, is climate change aside, nuclear is still a smart plan. Thanks again for the opportunity to speak to you today. And with apologies, I am going to have to drop shortly, but I'll be happy to participate in any Q&A until then.
So Peter, thank you very much. Excellent presentation. I love your facility. It'd be great to go out to the West Coast and visit that. How about any questions from the folks online for Peter?
Hey, Peter, Tommy Morgan, UCOR. You and I actually crossed paths briefly when you were heading out of TVA and I was heading on to Dan Stout's team there. But so we've seen a lot of good advancements in NRC policy and for advanced reactors, but have you feel like they have the adequate staff to handle the increase in non-light water reactor licensing work that you guys are involved in?
It's a good question. I'll give a qualified yes. Qualified because we haven't seen tremendous opportunity for resource challenges yet. We've certainly experienced problems in the past where everything was going great guns for Project X until Project Y showed up and then resources get shifted around. I do have pretty high confidence that NRC management is mindful of that issue. They have established for advanced reactor reviews the notion of a core team, which is a fixed team of people that will be available for reviews and with a lot more continuity than has been the case in the past. That's certainly helpful. It is on very near the top of our programmatic risk list, if you will. Not only in terms of NRC resources and watching to make sure that the resources are available and are committed and are available and remain available on a continuous basis, but also that what I call the sort of we hope the rest of the agency gets the memo issue, which is that we've worked with some really top tier NRC staff over the last couple of years on regulatory framework issues. The team that has reviewed our design specific submittals has been great to work with. And we hope that as those reviews propagate and as more and more content gets submitted to the NRC staff for the review, that the rest of the agency gets the memo, that the sort of risk-informed approach, the new ways of thinking, the innovations in process and in review criteria propagate as well, and that the rest of the agency behaves in that same innovative way. Time will tell. I'm cautiously optimistic.
Peter, I've got one to put a smile on your face. So I'm imagining how old you were when Duke Energy Services said, all right, go out to Las Vegas. What were they thinking?
I've asked myself that same question many times. It's funny, and this is sort of to tee off of the initial part of my presentation. If I were going to offer advice to somebody early in their career about how do you get into, how do you create the opportunities for leadership potential, particularly if you're in a company that's small and there's not a lot of obvious potentials for upside growth. And that's a really great example. So a good friend of mine with whom I had worked when I was at Oconee found his way into Duke Engineering and was out in Las Vegas. I was doing, pseudo lead engineer work on a high level waste program in the Charlotte office. And this guy called me and said, hey, we've got this set of analyses that nobody's ever done before. It's going to take a little bit of creativity and innovation and flexibility. And hey, can you be in a plane tomorrow? We want to borrow you for about 6 weeks. And I said, sure, sounds like fun. It ended up eating up every hour of my time between Thanksgiving and Christmas. And when I got home for Christmas, having completed that near-term assignment, I was met with a voice message that said, hey, we'd like you to come back and continue doing more of the same. And long story short, 6 weeks turned into 8 years, and several sort of leadership advances during that time frame. So, it wasn't it didn't seem particularly audacious at the time because it really wasn't. It was sort of we need these half dozen calcs done in the next 6 weeks. Are you available? And can you create the framework and the structure and knock out those calcs? And for what I had been doing, what I was capable of doing at the time, it wasn't a particular stretch. It was just something that needed to be done. But by virtue of demonstrating the willingness to do it, to sort of step into a new area and be willing to create the new process and see if it works, I created that potential, and they ended up standing up a team they didn't even know they needed. So, long answer to a short question, but it was sort of a turning point in my career. So I'm grateful for having had the opportunity.
I likewise have had a couple of those experiences, Peter, where somebody has said, "Would you go do this?" And I kind of looked at them and think, "What in the world are you thinking? I'm not qualified to do that." And basically they weren't qualified to do it either. They wanted somebody to step in that would take the risk, and they supported it. And most of the time, it turned out pretty well. So I've got one other question. As you're looking out at the world, you've done a substantial amount of work that benefits generally the industry. And you mentioned that you have one other competitor, Okla, that's in right now with an application, obviously NuScale, not a similar technology, but they're headed down the road. The US DOE has recently issued a fairly broad call for new designs. They're going to put a lot more money into new designs. Do you see others out there that have the potential to be really competitive, or is it just really a very small group?
It's a good question. So there's a Third Way. Third Way is one of the NGOs I mentioned, and they produced a new reactor developer map a couple of years ago. And there are, I don't know, 30 or 40 different bullets on that map. And there certainly aren't that many that are, I'll call it, I don't want to say serious, because they're all serious, but there are only a handful of those that are really engaged in a lot of significant work right now. But there are several that are really serious, by all appearances, really committed, and have the wherewithal to do it. And that wherewithal is really the differentiator for most of them. And in the case of many of them, it's a committed private funding that is really making the difference. And there's a lot of funding, there's a lot of capital out there. And there are a lot of people who are increasingly convinced that nuclear is an important part of the key to combating climate change. Bill Gates, probably the most well-known of the private capital people that are out there, actually funding nuclear development companies. His company, TerraPower, actually has 2 designs that they're pursuing with some amount of gusto. Terrestrial Energy is a Canadian company that also is by all accounts doing substantive work. And by the way, I don't think it's private. I don't think it's confidential, or they wouldn't have told me. But my understanding is they're moving their U.S. headquarters to Charlotte as soon as people are able to travel. You mentioned NuScale. Oklo is certainly out there, although just to clarify, they're not really a competitor of ours. We're after different market sectors. They're very much a micro reactor play. We're not. We collaborate with them often. Let's see, some of the more prominent ones also include X-Energy, the company that's not only developing a reactor, but also a fuel supply company. And there are several others. So I would say the number that I would count as sort of in the peloton of really active current developers is probably on the order of 8 to 10, maybe a dozen companies. There are a lot of others out there that are looking for opportunities to increase their efforts. a lot of sort of blue sky companies that are looking to do something as soon as the opportunity presents itself. And for people like Oklo, Jake DeWitt and Caroline Cochran are the founders at Oklo, good friends of mine. And for people like them, people like Kairos, our perspective is very much that a rising tide lifts all boats. And if we can be successful, then the much larger pack of people who would love to get into advanced nuclear development will have more of an opportunity than they would have otherwise. So that's part of our mission as well.
Peter, we're going to pause a moment and give others an opportunity if they want to come on off mic to ask a question. And if not, I've got a closeout question for you.
Okay.
How about other questions for Peter? In case you wonder why I'm looking off this way, I've got multiple screens. Peter's on that screen right there. So I'm looking at him while I'm listening and talking, but my camera's right here. Other questions? Okay, here's a closeout question. I understand that you've got to leave us in just a minute. So my last question, Peter, is that I see that, there are this large number. Third Way has mapped them out. When you take a look at the geographic dispersion, what you understand is that many of these companies are based on the coasts, kind of really broadly dispersed. And it appears that they locate near where their money is or where their founder with the concept is. So my question, as you take a look at what happens, you see that NuScale has a presence here, although they're headquartered in the Northwest. Kairos has a presence here. Yes, Terrestrial is moving down. We've been in discussions with them to help them identify office space. There's others that have some type of presence here. Do you see that a lot of these early stage companies are going to have to establish a presence in the Southeast just simply because of the talent and the research and the critical mass we have of nuclear service companies here?
I hope so. From a purely parochial standpoint, I'd love to see more developers located in this part of the country. Interestingly, the last few months have sort of changed some people's thinking about that. And so, for example, our office in Charlotte is not going to return to normal operations probably until well past North Carolina's phase 3, because we found that as much as we were communicating remotely with a much larger group in Alameda, dedicating the commute time to get to the office, maybe not a particularly attractive option. And so we may well spend half our time or more working from home for the indefinite future. That simply won't work in Alameda, where many of our team rely on access to the lab. And so where it makes sense to set up physical facilities by necessity, you'll certainly see a mass of people around those facilities. But when it came time to stand up our engineering test unit and our T facility, we picked from a list of locations. We ended up in Albuquerque. There were several other locations that were under consideration, and the possibility of access to resources was one of the significant criteria. So when it comes to standing up a new office, a new location, I think the Southeast, the Charlotte area in particular, scores pretty high in terms of availability of experienced resources. Interested companies, E4C certainly has a lot to do with that. Good, healthy transportation infrastructure, access to a good airport if we're able to ever use it again. All those factors I think will score favorably.
Super. Well, Peter, we appreciate you being with us. Great presentation.